Hello students, it's Dr. Church and we're going to take a few minutes to look at climate and climate change today. This is the third in our series on climate and will be the last for this section. So let's jump right in and take a look at what we've got. Climate or weather. The first thing is to note that weather is your particular condition of the atmosphere at a place and time, whereas climate is going to be the average weather over long periods of time in a region. So sometimes when we talk about climate change, we're not really looking at weather for just a season or a year. We're looking at weather over long periods of time and what we'd expect to happen there. So that's what the real issue is at times. There are natural processes that cause climate change. The question that is outstanding for us is climate change being caused, the climate change that we're noticing, is that being caused by humans? Can we control that, or is that just a natural process? And that is a question that is debated in scientific as well as political and social circles. But there are natural processes that cause climate change. Volcanic eruptions is one, just from ash and dust that get into the atmosphere, and that can affect the amount of heating. You've got ocean circulation. There are natural currents that, because of the uneven heating of the earth that we've talked about many times, will cause the oceanic currents to flow in certain ways because hot things rise and cool things sink. That happens in the oceans as well on an oceanic scale. And so those ocean currents will actually affect the climate of the continents that are near them. And so those things will actually affect the climate as well. Solar activity changes climate. You've got sunspot activity. So what is the gigantic engine that's heating the earth? Well, we know that that's the sun. And so there are fluctuations in the sun. As much as we would think that that's just constantly radiating energy at a very constant rate, it's not. There are actually variations. And so there could be some effects of that on the climate of the earth. Just natural processes of the earth's motion. The earth is not sitting still as much as it seems like it is to us. I mean, we know that we're rotating about the axis. We know that we're revolving around the sun, but we're also flying through the universe in the galaxy, which in itself is rotating, and there are forces that are acting in on a universal scale that may be affecting the climate as the earth and the moon and the sun are changing their relative positions to each other. So you can factor that in. This is a temperature versus solar activity graph. The solar radiation is given in watts per meter square. It's just if we looked at the heating of the sun over a particular area, we can see that this goes back to 1880. I didn't know they took data back that far on solar radiation activity, but there you go. The yellow line is solar irradiance. The red line is temperature. So we see a fairly constant or fairly even progression of solar irradiation, but the temperature still is going up. So we might conclude that the sun is not causing the climate to change per se, but it does have an effect on just weather and other natural processes, obviously. Now, what is the greenhouse effect? You've probably heard this many times, and it's just that natural warming of the Earth's surface. The sun radiates sunlight, which hits the Earth, strikes at a certain angle, comes into the Earth's atmosphere. It's reflected at a different wavelength of light, and therefore all the energy that gets in can't necessarily get out. And if that energy is trapped under this blanket of the atmosphere, then the Earth will tend to be warmed because of solar radiation being absorbed. So that's the greenhouse effect. It's a good thing that we have it, because if we did not have the greenhouse effect, the Earth would be a giant frozen ball. So you need carbon dioxide, that's CO2 in the atmosphere. The carbon dioxide is the CO2 which is in the atmosphere, and it's one of the greenhouse gases, one of the primary greenhouse gases. So climate change, we have seen carbon dioxide levels. They've gone back and looked at ice core samples, And if you look, you can see a bit of a pattern. That is because of these ice core the CO2 is shown in the ice core samples. They go back even 400,000 years, which is quite a long time ago. But from the 1950s until the present, we do see the levels of CO2 in the atmosphere going up. And so that's one of the key variables that science has pointed to in terms of the issue of global warming. So we've got data that goes back, a good 100 years, and NASA has tracked this. The Met Office Hadley Center has tracked this. The National Oceanic Observatory, they've tracked this. The Japanese Meteorology Agency has tracked this. So it's not just one organization, but they've looked at the annual temperature increases going back about 100 years, and we see a common trend there that there has been about probably a half degree shift in the average temperature since about between 1950 to 70 up till the present, which is around 2020. So how is the climate changing? Well, here's the outputs that we're concerned with. Temperatures continue to rise, which could elongate a frost-free season of growing. Maybe that's a good thing for food production. This change is predicted to continue throughout this century and even beyond. We do see an increase in precipitation, or changes in precipitation, increases in some places, decreases in others, heavier rainfall, causing flooding, and then droughts in other areas. And we've seen U.S. precipitation changing on average in at least the United States since about 1900. And so that's normally we want rainfall to be a fairly consistent, um, value. And so having it too much or too little is really not a good thing. We've seen hurricane activity picking up and stronger storms being produced. In the last 30 years, with the average global temperature increasing, and because we know that these strong Atlantic and Pacific storms are driven by uneven heating of the earth, if it's warmer, then those storms could certainly be a lot warmer as well, and a lot more severe. Okay. Let's see. We've got also this idea of the predicted sea level rise, where the global sea level, it was predicted to go up. Now, these are really hard predictions to make, and some people have made predictions on that sea level rise 30 years ago that have not necessarily come true 30 years later. And so it's really hard to predict what's going to happen in another 80 or 90 years. But theoretically, if all the Arctic ice were to melt, because ice, if that water then goes into the ocean, would that happen? I'm a little more iffy on that one, but that's definitely something that is talked about in scientific circles. Well, where does this increase in carbon dioxide come from? Well, the culprit pretty much is fossil fuels. And we've actually seen, if you go back and look, I'll have to add some of the recent data for the global pandemic has actually caused the traffic to be much, much less. We're burning carbon fuels at a much lower rate, and so that has significantly already impacted, even in 1 month, smog levels and certain pollutant levels and atmospheric levels that we can already measure. But burning of fossil fuels produces CO2, which is trapped in the atmosphere. And then to some extent, just the way that we do clear land for agriculture affects the ability of plants to produce oxygen from CO2. So where do we get energy? Why do we burn fossil fuels? Well, we burn them for energy. In North Carolina, as of 2016, about 36% came from natural gas and 33% from coal. In our state, that has changed a little bit. Probably natural gas is more now. We do have significant amount of nuclear power that powers our state, and so it's elimination of these two big items, the natural gas and the coal, that would reduce the CO2 emissions. So here are some of your green energy sources: wind, solar, hydroelectric, wave power. biomass, geothermal, and tidal power. And then here's your fossil fuels, which is your coal plant, your gas plant. There's your oil platforms for producing oil, and then nuclear power is actually not considered renewable because there's only a certain amount of uranium that's available to us. But it produces so much energy. I don't think anybody's really concerned about that so much at this point. This idea of eliminating gas-powered vehicles and coal power, and going over to renewable energy and then producing electric cars, it probably would make a significant dent in that. So that's one of the strategies that people continue to talk about, and it's interesting thing to consider. There's a Tesla electric car. That's the whole thing in terms of the mechanics of the electric motors are here, and they're driven. Each wheel is driven, or these two wheels are driven. Some of them are four-wheel drive, and then the body and everything just sits on top of that. So it's a very fascinating engineering design of the Tesla cars, and other manufacturers are beginning to produce those too, to meet that goal of reducing fossil fuels and switching over to clean energy sources. So there's just a little intro to climate change, and that's about as far as we're going to go with that. I hope that you guys are doing well. If you have any questions, you want to send me an email about the actual assignments, or any questions you have, let me know, and I'll be glad to address that. Thanks for your participation. Take care.